Some formula that's in your log table is called the binomial expansion. You might choose to use at some point. I have to say I very rarely use it. It's for multiplying out something by itself. So there it is on page 20 of your log tables. This is the type of question you might get, or it might be in the middle of a question. And over here is what I would do in order to expand it out. So it's called the binomial theorem, but often referred to, I call it the binomial expansion sometimes. So whatever question you're given, it might be something like that, where you just have to expand that out. So that's x plus y to the power of 5. And you might just multiply that by itself 5 times. So, get your answer, multiply it, etc. Or you could follow the binomial expansion. Now, what it says is whatever n is your power. So in this situation, my power is 5. So if I want to multiply that out by itself 5 times, but I want to do it in a faster way, I can use this here. So it's 5, choose 0. The first, so x just represents the first one, which here happens to be an x. I'll do it differently in a second. X to the power of 5 plus 5 choose 1. X to the power of 5 minus 1 by y to the power of just y, or y to the power 1, plus 5 choose 2, x to the power of 3, y to the power of 2, plus 5 choose 3, and you keep going up along like that. So now we can see the pattern. It's x to the power of 5, 4, 3, x to the power 2, and then if you look here, there's a y to the power of 0, a y to the 1, a y to the 2. So here's my y to the 3, 5 choose 4, x and y to the power of 4. So you can see the x's go down, and the y's go up. Plus 5 choose 5, x to the power of 0 is 1, and then y to the power of 5. What is 5 choose 0? So it's 1, x to the power of 5, plus what is 5 choose 1? It's 5, x to the power of 4, y, 5 choose 2, etc., etc. And you'll have it expanded in no time. It's up to yourself. Some people prefer to multiply it out by itself 5 times. They feel maybe that might be faster. But if you prefer, just get used to using the binomial expansion. You can see just the pattern involved. You just read your log tables and eventually you get your question expanded out. So let's go for maybe x minus y to the power of 3. Let's go for 2x minus y to the power of 3. To be honest, I think I'd just be multiplying that out by itself 3 times. But if we're just, for the sake of it, using the binomial expansion, what's n in this situation? It's a 3. 3 choose 0. And we have the first one to the power of n plus n, which is 3 in this situation, choose 1. And then we have the first one to the power, to a power below that, so going down 1, and then the other one, so the second one is a minus y. I hope I'm explaining this clearly enough. In this situation, the first one was an x. So it's the first one to the power 5, the first one to the power 4, the first one to the power 3, the first one to the power 2, the first one to the power of 1, etc., etc. You know, you're doing the n is 5, so it's 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. And then in this situation, the second one is a y. So it's, you know, here it's a power 0, but it's then y to the power 1, y to the power 2, y to the power 3, y to the power 4, y to the power 5. In this one, the first one is a 2x. So it's the first thing to the power of n, which is a 3 in this situation. So it's 2 to the power 3, sorry, 2x to the power 3, because that's the very first thing, 2x to the power 2. So the next one will be a 2x to the power of 1. And we're looking at 3 choose 0 plus 3 choose 1. So now we're looking at 3 choose 2. We're looking at the second one is a minus y. Remember, if you look at the binomial expansion, it's x plus y. And my one is a 2x. Mine's a 2x, technically plus a minus y. So 2x is the first thing, and a minus y is the second one. So we have minus y to the power 0, minus y to the power of 1. So now we have minus y to the power 2, the second one to the power 2. And then we can just keep going until we have up as far as 3 choose 3, which is actually next. So 3 choose 3. We have the first one going down in powers. So this would be now to the power 0. So it just turns, you know, disappears or turns to 1, let's say. And we have the second one is going up. So the second one is a minus y. And it is to the power of 3. If you work this out, that's the same as multiplying this out by itself 3 times, expanding it out. 3 choose 0, anything choose 0 is 1. 2x to the power 3, that's 2x by 2x by 2x, which is an 8x cubed, plus 3 to the power 3 choose 1 is 3. 2x to be squared is a 2x by a 2x, which is a 4x squared, by a minus y, plus 3 choose 2 is 3, and 2x to the power 1, and minus y to be squared is a minus y by a minus y, which is a y squared, plus 3 choose 3 is 1, and minus y cubed to be cubed is minus y cubed. And then so when I clean all that up, that's 8x cubed minus 12x squared plus 12x squared y plus 6xy squared minus y cubed. And if you want to check if I'm right or wrong, just in case, the other way of doing it is to just multiply that out by itself 3 times. 2x minus y by 2x minus y by 2x minus y. Did you get the same as what I got here using the binomial theorem, which is found in my log tables?